symbol with the 3 outside. Have you guys ever used that before? Or if you're trying to undo x to the 4th, you need to use the 4th root. And I'll show you how to do that on the calculator. Or the last method we can use is called, this sounds a little weird, and I don't know where the name comes from, synthetic division.
Huh.
Have I heard of that before?
No.
It's not too hard. It's actually kind of fun once you get the hang of it. Although I think it's fun. I don't know. I don't think it makes it fun if you guys think it's fun. Okay. So, another thing we want to talk about is called the multiplicity of zeros. Okay? Remember, and I think I wrote this down for you guys last time. I just didn't use the word multiplicity. So if the 0 is repeated an even number of times, anybody remember what will happen to the graph? It's been weeks since we talked about this. An even number of times. So it's like I have 2 zeros that are the same. What will happen is the graph will just touch the axis at that point.
Am I just really low on caffeine, or I'm totally missing this?
So if you got your 0, I'll do an example in a second.
Okay.
Hopefully that'll make it make more sense. Okay, your 0 is repeated an even number of times across the axis at that point. Or no, you'll touch the axis if it's an odd number of times across the axis.
If it's even?
If it's repeated an even number of times. Okay? You're repeated an odd number of times. The graph will, maybe I'm wrong about this too. Not touch the axis, the graph will cross the axis at that x value.
So how do you find the number of zeros?
Well, the number of zeros that are possible is the degree.
Okay.
Okay? And then you would figure out how many times it's repeated by, you'd have to factor it. Okay? So let's look at an example here. And let me give you one that's already factored. Okay? Let's do this on a separate sheet of paper for me, please.
So if it's an odd amount, the graph will cross the x-axis at that point.
Alright, so let's say y equals 3x plus 2 times x minus 2 squared times x plus 1. Okay, first of all, just for practice, what is the degree and what is the leading coefficient?
The degree is the exponent, right?
The degree is the exponent, the highest exponent if you've multiplied it all together.
4.
It would be 4, right? Because I've got x times x minus 2 squared, that's x squared, times another x at the end. So I've got x squared, and x. Multiply all this together, you have 4 x's.
Okay.
And what is my leading coefficient?
3 times.
Well, the degree of the first x, or the coefficient of the first x is 3. Coefficient of the second one is 1. Coefficient of the third one is 1.
Yeah, so 3.
So you have 3 times 1 times 1, which is just 3. Okay. Now let's find the zeros. How would I find those zeros? This is already factored for me.
The number of degrees. So there'll be 4 zeros.
There'll be 4 zeros.
And it's even, so it's going to stay on an axis.
How do I find the zeros then?
Set it equal to 0?
Once you've got something factored, remember with the quadratic, you factor, and then you set your factors equal to 0. So this is already factored for me. I can just set my factors equal to 0. Okay, so my individual factors are 3x plus 2. I'm going to set that equal to 0.
And since the x minus 2 is squared, they're going to have 2 of those,
I'm
right?
going to have 2 of those. But I only need to solve it once.
Yeah. Just keep in mind you have to put it in there
You can solve
twice.
it twice if you want to. And then the x plus 1. Okay? So, x minus 2 equals 0. I know that would give me x equals 2. And that's the one that's repeated twice. So that kind of counts for 2 zeros. Okay, x plus 1 equals 0, I know would give me x equals negative 1. And that's only repeated once. What about 3x plus 2 equals 0? Not 2/3.
3/2.
2/3 is closer. Negative 2/3. You have to subtract 2, divide by 3.
So we found this out. What do we do with this?
You can sketch the graph from this. Okay? So I know I can figure out what the graph would look like. I know my zeros are at negative 2/3, negative 1, and positive 2. Okay? I know that my degree was 4, which is even. My leading coefficient was positive, so what should my graph do? Is it up, down?
It should be
Go down.
down. It should be both. It should be a parabola, and it should go down, right?
What was my leading coefficient?
Well, if you should,
On the 4.
Positive. It should go
up.
up on
Oh.
both sides.
never mind that.
Up on both sides. So I'm going to come down from here. Negative 1 was only repeated once, so I should cross the graph at negative 1. Okay, then I'm going to have to turn and go back to negative 2/3. And I should also cross the graph at negative 2/3 because that was only repeated once. Okay, then I'm going to have to turn somewhere and go back to positive 2. So positive 2 was repeated twice, which is even. So I'm just going to touch the axis there. Bounce off it and then go back in the other direction. And then go back up.
So because it was repeated twice, we know it's only going to touch the axis.
It's
and
only
then
going to touch
cross
the
through
axis.
it.
That's what that tells you.
Oh, so we can. So when you say if
Okay.
the degree is uneven, you're really meaning like how x equals negative 2 or 3 is uneven amount because it's 1. We know it's going to cross through that instead of just simply touch the x-axis there. Okay.
You gotta get it repeated twice.
But we're not. But how do you know where
Break
it's
each
gonna
one
cross
apart.
the y-axis? I mean, how did you just know
I
to?
don't. That's why I didn't label it.
Oh.
That could be anything.
So
But I know
you're
the
not
rough shape of the
really
graph.
You're just.
You're getting the shape right.
You're getting the estimate of.
Yeah.
Okay.
Yeah. They don't care about the y-axis that much. Okay, but that's how I would sketch the graph.
What is this called?
The repeating even or odd thing is called multiplicity.
Okay.
Now there's not very many questions about that, so I wouldn't worry too much about that. Okay, the main thing is actually finding the zeros. Okay? So let's look at another problem where we have to factor. Now I think the first question is where what we just did, where you just set the factors equal to 0. Like what we previously did. You know what I'm thinking? Okay, well there's a couple equations here that are already factored for you. So just like we just did, you would just set those factors equal to 0, solve for x. Okay? If you have anything repeated, you don't want to list them twice. Okay? So like here, I'd have x plus 3 is squared. I don't want to list -3 twice. I only want to list -3 once.
But since that's a even number, we'll know it's just going to simply touch the line at that point. Okay. I like this.
So if I look at this equation, okay, I want to set these factors equal to 0. Okay, so I'd have -3, +9, and then the last one I would need to add 2, or add 7, and divide by 2. So if I added 7 divided by 2, that would give me 7/2. Okay? All I was trying to say there is that since the x plus 3 is squared, you don't want to answer -3 twice. You only want to list that answer once. Okay, so I would just list my answers as -3, (9), (7/2). It does not care about the order. So if you think it's counting you wrong because of the order of your answers, then something else is wrong.
So that's how we're going to write it out.
It could be the commas, it could be the negatives, it could be the numbers themselves. The order does not matter. Okay? But you do have to have the commas in between them. Okay? What about number 3? Number 3 is one where I have to factor myself. So if I have x cubed minus 16x, I'm going to do that thing where it doesn't let me write it in this one. Okay, it tells me to solve by factoring. So how can I factor this? What can I factor here? Okay, I've got an x in common that I can take out. So let's take that x out. That leaves me with x squared minus 16. Okay, and then what am I dealing with?
A difference of squares.
Difference of squares, exactly. Difference of squares factors 2. Square root of 16 is 4.
Square root of x is x.
So I have x minus 4 times x plus 4. Okay, and then I need to set, I've got 3 factors here I need to set equal to 0. So I equals 0 and x plus 4 equals 0. Okay? And then that gives me my 3 answers. I have 0 as an answer. I have positive 4 as an answer, and I have negative 4 as an answer.
So how did you write that out?
What?
How did you write number 3 out? It was x.
Oh, it was 0, 4, negative 4.
Okay, so x itself is just simply 0 because x equals 0. Okay, that makes
That
sense.
single x that you took out will always, if you factor out an x before you do anything else, it'll always give you 0 as an answer.
Okay.
Because if you plug in 0 for that x, then it make the whole thing 0. Okay, now there's a couple like just like that one, so let's get those. Okay. What do you guys do when you see 4 terms? Like on number 5.
Combine like terms?
What?
Do you combine like terms? No, there's no like terms.
There's no like terms. What is the magic word for 4 terms?
Private?
We want to use factoring by grouping.
Grouping?
Okay, it's kind of like part of the AC method where you have 4 terms and then you factor the first 2 and the second 2. Okay, when you have 4 terms and they give you 4 terms, you want to use factoring by grouping. Okay, it's not working here. Okay, if you've got 2 or 3 terms, usually it's you can factor out something and then try to use the difference of squares, or you'll just be left with a quadratic. If you've got 4 terms, you need to use grouping. Okay, so remember with grouping, I need to look at the first 2 and the second 2, so I need to use 2 groups of 2. Okay, and then I want to take out the greatest common factor from each group. So my first group is n cubed minus 7n squared. What's my greatest common factor?
The n.
It would be
1 n.
n
Oh.
squared.
Yeah.
And if I took that out, it would leave me with
n minus 7.
n minus 7. Okay? Now here's a trick. Now I just know this trick from doing a lot of these. If you've got a negative in the middle there, then what you are going to take out of the second group needs to be negative. Okay? Now n plus 7 doesn't have any, they don't have any common factors. So what I need to take out there is going to be negative 1. Okay?
Wait, can you take a negative 1 from a positive 7?
Mm-hmm.
So it's just like subtraction?
It's like dividing by negative 1.
Oh.
Okay, so if you're taking a negative 1 out, it's like dividing by negative 1, it's just going to flip your sign. Okay, so if I take a negative 1, divide negative n by negative 1, you get positive n minus 7. And the other reason I have to do that is because I know what my parentheses have to match. So if I had n plus 7 there, that would not work. It wouldn't match. Okay, so if you've got a negative in the middle there, you're always going to have to take a negative number out of your second group, which is going to flip your sign. Okay, and then how would this factor down to my next step?
Wait a second.
I'd have n, what's in front, n squared minus 1, and then n minus 7, just 1.
Oh, I remember this now.
Now, can I go any further with this? N squared minus 1 is, again, difference of squares. Okay? Okay? So that would factor to n plus 1 times n minus 1.
So where did our other n minus 7 go? Why did we just get rid of that?
Because they're the same, n minus 7 and n minus 7.
It's like you're factoring out that whole set of things. You factored out that whole parentheses. You take it out
Oh,
once, and then
okay.
you're left with what's in front.
Gotcha.
Do we count that as a double? n minus 7?
No.
Okay.
It's only there once.
Okay.
It's only there once. Okay, so my zeros here are going to be -1, +1,
Positive 7.
+7.
Why don't we count n minus 7 as a double?
It's not squared. There's only one of them.
Okay. Well, there's two of them instead of the.
No, when you factor that out, you factor it out as only there once.
I'm trying to think of this.
I'm still lost on that too.
I refuse to accept.
Alright, let's try to go over this again. Okay? This is what we're factoring out. Okay, we're factoring out n minus 7. Because if I look at this as a group, and this as a group,
They have that in common.
they have that in common. Okay? So I'm going to take out that whole thing of n minus 7. Okay? Now if I take out that whole thing, because that's what they have in common, that would leave me with the n squared minus 1 left over.
So those are common denominators is what they are. Or
The common factors.
common factors, yeah.
The parentheses is the common factor. So you take out the parentheses from here, that leaves me with n squared. You take it out from here, that leaves me with the minus 1. Okay? It's because I factored it out that it's only there once.
That makes a little bit more sense.
Okay? Now I wrote it in a different order there, but the order of your factors really doesn't matter. You can switch the order, it's still the same thing. Okay, now I think there's a few where you have to use factoring by grouping. And then let's talk about the root method. Do you guys want to try number 7 on your own? Just for practice? Why don't we do that? Let's try number 7 on our own.
You want us to put it on that paper?
No, you can do it in your own.
I'm still trying to do number 6.
Try number 7 to make sure we can all get number 7 here.
Yours is exactly the same.
Okay.
No,
That's an example.
well, no, that's what you would
You
do.
can still take a 4 out of here.
Look, if you notice these.
You have a negative 4, it's going to be minus 1 because of your sign. If you took out, you're actually going to take out a 16. Because if you take out a 4 and then another 4.
I'm really confused. Okay, I know I can take out x squared here. And then
So
that's
you want to
gonna
think
leave me
about
with
dividing
this.
both of these by x squared.
Let's,
So you do
let's
2x
keep
cubed
factoring
divided by
ahead
x
of time.
squared.
Just simply
It's just
turn
gonna
them into
be
those years.
2x.
2x, okay, so you have a 2x. And then if you have minus x squared divided by x squared
Minus x.
is minus 1. Because the x squared cancel, you just left the minus 1. Okay.
And that's good.
Because you do 32x divided by negative 16.
Right.
2x. And then 16 divided by negative 16.
Right. Yeah, this is what I was confused with. Okay, so then I put these two together. X squared.
Maybe. What they do is they turn them
And
into
then I just
And it's the x squared because there was no x there. Now what did you take out here? What did these, what was the common factor?
2.
Because if you don't change that,
No,
it's
you
happening
took out, looks like you took out a 25. Because you 25 times 2 is 50. 25 times 1 is 25. So you need a 25 out present.
And this one, the common thing.
So you factor that out.
So what happens to those square over here then?
That should not be there. If you took out x squared, if you took x squared away from x cubed, you just have another x.
Is that right? I guess because I got it 3 times my 30.
The equation is multiplying, or it's just, it's changing. I'm looking at it.
I think I'm too tired to do it. I'm exhausted.
2.
Oh, did you? Oh, yeah.
So this, that's 55 for that down here?